Hello guys, welcome back to John's Workshop, and in this video we're going to start off a new project which is to make something completely different from what I've seen any other YouTuber doing, and certainly in the community of sort of YouTubers that I watch and most of the people who watch me watch. So I've had a request come in from a customer, bit of a special customer in this case. This is for my dad, and he's a keen golfer, which isn't bad at 82, pushing on 83, so he still manages to get out as and when he can in the current climate and also the weather and everything else. So he's asked if I'll have a go at making a putter head for him. So he's given me a bit of a drawing, so I'll bring you in a moment and show you a bit of the drawing. It's going to be a real challenge, is this. There's some interesting geometry on it, but it's going to be a really good project to make use of my new small rotary table that I've got, so we'll give that a go on the mill, and also the first proper project that I'll be able to make use of the fully working DRO that we fitted to the mill. So looking forward to this one. This one's going to be something a little bit different and something a little bit interesting. So there we go, the putter head for manufacture. It's not on that side, obviously. So we'll have a look on the other side and see what we've got. So you can tell this has been drawn by somebody who's spent time in engineering. So my dad spent most of his working life in engineering of some form or another, and he's drawn this up. So you can see he's used proper elevations to sketch out what he needs. There was a couple of queries on the drawing and I've cleared that up with him. We're going to basically, there's some really interesting geometry on here, some that's not quite shown on the drawing, but I'll tell you a bit more about that as we get into it. So yeah, you can see there's some strange angles, there's some clearance that needs to be machined on the back edge that's not really shown for the ground. There's some reliefs to be milled into it for sort of line of sight, that kind of thing. There's some cross hatching to be milled into the front face of it, so that's going to be a really interesting thing to do. Never done anything like that before on a milling machine. And some general dimensions there, and you know, none of these are fixed and firm. This is general, somewhere near. Obviously there's going to be difficult to get to features like a sharp point corner here. You know, with the best will in the world, I'm not going to be able to mill that out. So again, I spoke to my dad and said, is that just weight relief and whatnot, or can I have a radius in this bottom corner? He said yeah, no problem. So that opens up the possibility to mill this. So what we've done, I've ordered some, originally I was going to look for some stainless steel for this, and it's a minefield, honestly. I think it must just be this section and size that I needed stock wise, but to buy a lump of stainless steel to make this from the sort of sources that I've got open to me where I live and using the internet and whatnot, it was going to be stupidly expensive. So we're going for, we'll class this as prototype, so we're going to go for mild steel on this one, and it'll need some form of protection, which will come in the form of paint, I'm guessing, or something along those lines. So this is going to be mild steel. My steel's turned up for making this, so I'll join you at the saw just shortly and we'll be cutting off the blank to start machining this out. Well, that's ruined that. I was hoping it was going to hit the floor, so I could have said that won't be the first time this hits the ground. Anyway, there we go. That's got that cut off. So we've loaded this in the vise on the two sort of parallel sides, or the most parallel sides. The first job we're going to do is just get this roughly blocked out to our finished sizes. So the first part of the sort of shaping I'm going to attack is there's a relief towards the back of the putter head, and there's a couple of dimensions missing off the drawing, so I've got a bit of poetic license. So I'll scribe myself a line where there is a dimension, and I'll break out into that line, and the thickness that's remaining at the bottom is undimensioned, so I'm kind of just roughly scaling it off the drawing at that point. So we'll machine it back to that line, have a look at it, see if it looks about right. If not, I can always just slightly alter the angle. I'm erring on the side of caution, so I can always take a bit more material off. So we'll start machining that now. Right, we're on with the next step with this now. There's a few ways I could have done this, and I've chosen probably the easiest way. So I've blacked this up with a Sharpie pen where I needed to. I've put some scribe lines in the right places, and I'm basically going to work to my scribe lines. So I've got some material first to come off each side at the front here, and then once I've done that I can then set up around these scribe lines and machine the next two features. And then I shall do a similar thing, scribe the lines across the back for the next couple of angles I need to do, and just do it the same way, working to the scribe lines. So that's what we'll go. We'll set the mill up now, and we'll start machining some of this stock away. Okay, well, we're on with the next setup now. So we're going to produce this next angle where my scribe line is on the part there. And now we've set this up, I'm just using a parallel that's got really nice sharp corners on it, and I'm just eyesighting till I split that scribe line. So you can see that there, and if I zoom you in, you can see the scribe line there quite easily. In fact, it's easier to see on the camera to set it up than it is with the naked eye, to be honest. So I'm fairly confident that's pretty well lined up on that scribe line. So we'll start machining that corner off now. Well, I've had a bit of luck with this last angle. So the last angle I want to put on is going across there like that, or either side, both the same. The distance from the back face to the transition is exactly the same as the distance from here to this transition, and it's the same angle. So I can sit on this face to machine this angle, and this face to machine the opposite angle that side. So I thought I'd been clever, and I thought that was all going to fit just nicely right on the bottom of the vise like that. But unfortunately, as I shut the vise, this back piece here is just catching on the nut inside the vise. But I think we can sit it on a parallel just like this in the middle, and I should be able to feel when that's sat flat down. That feels good. And close the vise up at that. I'm now clearing the nut in the middle of the vise. Take the parallel out. And all I need to do now is machine this angle down here until I just blend in with this corner where all three angles meet together. So we'll just get set up for that now and start machining that side down. Right then guys, exciting times. My new to me Toolmaker's rotary table is loaded up onto the bed. I've had a bit of a win and a bit of a lose. So the bit of a lose is I'm already suffering from my decision to put the XDRO scale on the front of the table. As you can see, it's a real shame that, and I think I might look at extending the arm here on the handle, because I'm literally, I don't know, 10mm probably, something like that, 3/8 of an inch away from being able to line the slots up on the T-slots of the machine and still clear the scale. Anyway, so that's the bit of a lose, but that's all modifiable. I think we can change that. The bit of the win is the vice clamps that I made in one of my earliest episodes for clamping my machine vise to this mill are exactly the right height in terms of the step at the back for clamping the rotary table down, so that made that nice and simple. So we've clamped the rotary table down. I've not clocked it circumferentially anyway this way on the casting, that really doesn't matter for this job. I've clocked the centre of the table, so my spindle is now currently sat bang over the centre of the table rotation at the moment. I've marked my part up with a scribe line on centre line, and you can see how I've got it set up. I've got it on a big parallel, some clamps. So next job now is I'm going to pick I've got my centre finder in, we'll start that up, set it running true, and then basically I've not tightened any of this down yet. I'm going to adjust the part until my centre finder is bang over that centre line that I've scribed on the part. At that point I'll know that my centre line is bang on the centre of rotation of the table, and then I'm going to pitch across this way with the part until I'm about 1.5 mm ish, yet to be decided. I need to calculate that, away from the transition here. so I'll probably scribe a line when I do that. I've still to work that out, so I just thought I'd show you this setup. So I'll just calculate where I need to be, scribe my line, and then we'll set the centre finder going, and we'll set the part up relative to the centre of rotation of the table using the centre finder, and then we'll get everything clamped up. So I'll bring you back when we're doing that. There we go, that's us right over the centre, so I'll get that clamped up now. What I forgot to say, and should have said, is my new rotary table, courtesy of Alan, on the south coast of England, who sent that up to me. So there you go, Alan. I did promise you it was going to get an airing at some point in the next few weeks. So this is the first setup we're going to use this for, and the next setup after this, on this same part, we're going to still use the rotary table, but in a slightly different manner. Right guys, we've got the clock on the front face of the part now, so we're just going to tram that in using the rotary table. So we'll have a look at what we've got. So we've got a good turn there. So we go sort of half a turn, I don't know, somewhere like that. That's going plus 2 or 3 thou. If we bring that back to there, oh, wrong way, bring that back to 7. So that's just clocked in there now. Right guys, we've got a 7mm slot drill in there. So I think what I'm going to do is just, I've locked my y-axis off on centre, so I'm going to touch off at that point, and then I'm going to come away in X, and I'm just basically going to pick away and just put a parallel slot all the way through the part up to my 0 position, and then we'll cant round at the angle one way and the angle the other way to put the V in. So we'll just have a bit of a go at that now and see how it's going to cut. Right guys, we've got the slot in the centre all the way through there now, and what I've done is I've done some quick trigonometry to work out. I've got a finished width to work to here that I know what it is. I know what my length to the centre of the radius is, which is the centre of my rotary table, and that's why I've set it up that way, so that I know the centre of the arc that I've put in at the bottom of the slot is bang on the centre of the rotary table. I know my distance from that centre to the front edge, so from that I've calculated using trigonometry where my what my angle needs to be. So it's 7.4 degrees, So we've set that for the first side, so the next job now is to mill this side at 7.4 degrees and blend into that radius in the bottom, and then we'll flip the opposite angle and do the opposite side. Right guys, next operation, while we're still at the same setup, I know I'm on my centre line this way from putting my groove in the back. So what I've got here, and this isn't exactly ideal, so I've got my ER32 collet with an extension shank with an ER11, so an ER11 collet and a 3mm solid carbide end mill. So what we're doing now is putting a groove in the face of here for eyelining or eyesighting the direction of the put effectively. So this is going to be just a straight line groove put in there that probably get filled with paint or something like that, which will give you your sort of direction, angle of orientation of the putter. So we'll get on with that next. Right guys, here's the next setup now. So we've got the only angle plate I own, which is this little tiny one, onto the rotary table, clocked up against the y-axis, and we've got the part clamped to the front just with the toolmaker's clamp, but nice and tight. And the next job is I need to put some serrations, crosshatch, whatever you want to call it, on this front face. So this is the face that makes contact with the golf ball, and that's just to give it some grip. So effectively what I was going to do was tip my head over at 45 degrees. We're going to move this round on the rotary table at 45 degrees in one direction and then back at 45 degrees in the opposite direction. And the plan basically was to use an end mill, sharp cornered end mill like this, with the head at 45 degrees, which effectively would then put a groove, a V groove, a 90 degree V grooves across the face in one direction and then in the opposite 45 degree direction across the face. I've thought about this some more, and we're going to try something different rather than tipping all the head over and having to tram it all back up again, which I'd kind of set myself up for, but I've decided to back away from it. For what this is, the golf ball is never going to get near the bottom of these grooves, whatever, that it's not really used to grip like a vice jaw would be used to grip. So I've got myself a 2mm diameter ball nose end mill, so tiny little 2mm ball nose end mill. So rather than tip the head over at 45 degrees, I'm going to use a 2mm ball nose end mill to put the grooves in. So all we need to do is slew the part over at 45 one way and 45 the other, and put a series of grooves in the face. So we'll give that a whirl and see how we get on. there we go guys, that's done a fair job of that I think. Quite pleased with that, very neat looking. Just going to run a wire brush over that. It doesn't feel like there's any real burrs on it. There will be on the edges where I've broken out, so I'll just use a little rat tail needle file just to break those edges on the, you know, on the very edges here. But in terms of the actual face itself, I might just run a gentle wire brush over that just to get rid of any burrs. But that's come out. Yeah, I'm quite pleased with that. First time I've ever done anything like that really. So and the 2mm end mill survived. Alright guys, I've got a few more operations than I thought left on this. I think this is far too heavy, just by holding the weight of it in my hand, and I've dabbled a bit with golf on and off over the years. I'm no golfer, but I think this is far too heavy. This is more akin to a driver than it is a putter. I think if you drew this back 3 inches behind the ball and gave it a tap, I think you'd be straight out the back side of the green. So I've spoken with the designer this afternoon and we've had a bit of a discussion. So what we're going to do is put some weight reduction features into it, and I want those to be presentable rather than just drill loads of holes in it everywhere to get some weight out. On reflection, we should have made this from aluminium and maybe had a front end that attached to it that was stainless or something, but you know, that's for Mark II. So rather than just put holes in this everywhere that are going to fill up with grass and dirt and whatever and be difficult to clean, I've got a bore nose end mill in here, and we're going to put some semicircular, for want of a better word, slots in. So I'm going to run a slot up this side, we'll do the same on the opposite side, and then I'm probably going to transition that slot through into this face here, so we run up the angled face with the same slot, and that then keeps the weight distribution somewhere near correct over the whole part. Okay, so we've done with the weight reduction slots on the side now. The next job is to put some clearance on the underneath, and it'll be from sort of the edge of the vise here. This isn't brilliant because it's not ideal just clamping on one edge of the vise, but I'm going to go really steady with this and just create some clearance relief on the front side of this, and then we may even tip it up and make some clearance relief on the back side as well. So basically the underneath of the club then becomes an arc shape, which gives clearance. If you think of this on the end of a shaft swinging against the ground, it's going to strike an arc sort of against the ground, so we're going to create some clearance that roughly resembles that just by milling 2 angled faces. So we'll start off with that now and see how we get on. Right, we're going to very roughly, and I mean very roughly, determine the centre of gravity front to back. So I'm lining this up by eye so it's square, and basically bringing it until I can feel it tip there. So it's tipping back. I don't know if you can see this, it's tipping back there. If I roll it forward on that pin, it's just starting to tip forward there. So all I'm going to do is eyesight centre of that pin, just double check it. Yep, and that's where our centre hole's going to go. Right, we're just going to bore this out now to 10mm using an M-mil, and because we've only left 12-13 thou in there, that should leave us a nice exact 10mm hole, hopefully. So we'll just do that now. Right guys, branding in more ways than one. So this this putter's called Top Cat, and I think that's my dad's nickname on the golf course because his initials are TC. So we might as well have a go at doing something with that. So I've got my stamp set out. I've got the right stamps out that I need. I've clamped the part to a nice solid steel block, all clamped up to the bench, and I've got a straight edge that I can use here for holding the stamps up against. So we're going to do one at a time, and then when I'm positioning the next one I shall put the previous stamp in the letters that are letter that's already there, and that should give me the spacing between the letters going along. The dangers of this going wrong are many, because from where I'm stood I'm stamping both upside down and back to front, so there's every possibility that this is probably going to say tack top or something by the time I finish, but we'll give it a go. Right guys, with a bit of tweaking and a bit of firework, I've actually managed to clean mostly up that double stamp that I'd done on the T. So that's pretty good, I think, at that. So next job now, thorough degrease all over. I've been all round and chamfered, done some good firework and tried to keep all the break edges the same size all the way around the whole thing. So next job now is to give this a good degrease and get it into the chemical black. So I'll do that next. Well, there we go guys, that's it all finished and complete. We'll just zoom in. So there you go, that is the Top Cat putter. So we'll see how that goes. It obviously needs a shaft fitting to it and it needs to be trialled. There's various design features that have gone into that by my dad, who's played golf for many years and tried different things. He's actually made a prototype out of this, out of wood, to trial the concept. I still think this is a bit heavy, if I'm honest, but we'll see how it goes. I've done my best to lighten it as much as I can, but yeah, pleased with that. Something a bit different. Nice work on the front edge there, and yeah, very prismatic shape, lots of angles and various different things, and you can see the angles underneath you can see this, the clearance now on the ground, the sweep front and back. So yeah, there you go, that's the top cap butter. So I hope you found that interesting, something a little bit different, and I will report back when I hear how successful or not that is. So thank you all for watching, thank you all for subscribing as usual, and we'll catch you all very soon on another video when we'll be making something else. I've had a spot of luck. Just the way this is designed, the angle that's to go on this back piece is exactly the same as this angle or this angle. They're all equal angles all around it, and because of the way my vise is configured, I can sit on the opposite angle, on the opposite side of the block, on the base of the vise, and that's absolutely perfect. I don't need to do any marking out. All I need to do now is remove that material well, that shot that theory up the